So for the folks at home, Josh has his hopes on Artemis 2.
I wouldn't say hopes is accurate. I'm just excited.
In 2 weeks, Josh, you'll be sadly disappointed. Hold on to the edge of your seat.
Well, I mean, yeah, it's NASA. They don't have the best video equipment compared to commercial companies, but
It's not NASA.
Still cool
It's Elon Musk. It's not NASA. It's a dipshit
no,
that thinks he knows what he's doing.
No, that's not true. Artemis 2 is space launch system and Orion spacecraft, both built by NASA.
Oh, it's all NASA, no SpaceX?
For the Artemis program, correct.
Oh, okay. Still bullshit. Still not going to make it. Still not going there. Still a waste of money. Still a homeless person on the street.
Sure. You have every right to that opinion.
Josh, I've got a question for you. So when they launch the rocket, into space, they're going to punch a hole through the container, and all the air will rush out, and somehow they're going to seal up the hole, and everybody on Earth will be okay. Is that correct?
No, there's no container.
So the atmosphere of the Earth acts as a container. Is that what you're saying?
No, he's saying we're breathing air next to a perfect vacuum without any container is what he's saying. There's no issue there.
Correct.
So the natural and physical law, the gas laws, has no effect. We just have to ignore it. That's it.
Well, it's not a perfect vacuum, right? It's just a pressure gradient asymptotically approaches zero. There is no such thing as a perfect vacuum.
But anyway, their claim is, they're going to launch a rocket into space. That means they'll have to punch a hole through the container.
No, it doesn't.
I know the container's unbreakable.
No,
the container's unbreakable, so they're not going into space. The rocket's going to go up and it's going to come back down. That's it.
You're presupposing a container with no evidence.
It's just another made-up story, Josh.
Disagree.
Okay, that's fine.
I was going to say, you have to presuppose a container to have to break through a container.
Yeah, like antecedent for fire. So presuppose the antecedent for gas pressure. It's normal.
Well,
Let's say
gas pressure asymptotically approaches zero.
Fire, you'll just say to that fire investigator that, you're just assuming that there is something that can catch the fire. There is some oxygen, and there was something that started the fire, some heat. It's not presupposing.
Not following the analogy there. No. I mean, gas pressure. You can launch weather balloons. At altitude, we see that pressure asymptotically approaches zero, so there's no need for a container.
Yeah, there is a need for a container because gas pressure gradient, you can't have it without a container. You can't repeat a demonstration with having gas pressure gradient without any container.
That's not at a celestial scale. No, you're just saying just because we can't build something at human scale doesn't mean that it can't exist. Like that.
No.
That's your assumption there.
It's the correct scale. You will just have to do that on the surface of the Earth, where you claim that it's gravity that's creating that gas pressure gradient. Yeah, you will just do it on the surface of the Earth, where you have potential of gravity. So you can just create a container, create 1%. And that container will just have 14 psi, and the rest of the container will be just 90%, 99% of that container will be just.
No, I mean you can see gas pressure without a container at celestial scales by doing spectroscopy and pointing at Mars or Venus in the sky. Like you see the spectra of CO2 coming off of the edge of Mars, and as you move off the edge of that light, the CO2 spectra disappears, and there's no delineating barrier where you have some other element that is solid at ambient temperatures and pressures. So you can look up in the sky and see an example of gas pressure without a container for yourself. Like it's you don't have to presuppose there's a container there. I disagree with that assertion.
Yeah, because you can isolate everything that is in between you and that thing that you are doing spectroscopy to.
Well, no, from the ground you can't. So then you have to go out and do airborne platforms. You have to do,
Yeah, like Muhammad,
space platforms.
Like when Muhammad went to see his God. So I just have to assume those
No,
stories from your
you
prophet.
can go build it yourself. You don't know. No. If you think they're stories, you go knock on the door and you go build it yourself. Like I don't.
Build what?
You're not. Oh, build a satellite, build a space system, go get a PhD in astrophysics. Like you don't have to just sit on your couch and say you can't do it. Like there's people out there that are more than willing to share their expertise and to help provide you the resources to go answer these questions for yourself. So, it's not just saying like, oh, there's a container, oh, we can't do that, oh, they're all stories. Like, just sitting here on Discord, that seems
Yeah,
kind
you
of
can
like
do it yourself.
assuming ineptitude.
You can do it yourself too. You can just hop on a Pegasus like Muhammad did in Islamic religion. You can hop on the back of Pegasus and you can go to see God. Yeah, you can do it yourself.
No, that's not true.
Josh, Artemis 2, they got a David Suzuki or just a regular Joe going on that trip, or are they all handpicked
No, the
by
NASA
NASA?
astronauts. Yeah, the NASA
Best of the
astronauts.
best, right? Best of the best.
One sec, hopping in an elevator, y'all. I'll be back in like 15 seconds.
Yeah. Best of the best, folks. All signed an NDA. All handpicked by NASA themselves. I'm sure we could trust whatever they're going to tell us or show us. We'll know it's real because it'll look so fake. Come on, obviously they're on the moon.
All right, we back.
They could have faked it better than that if they wanted to fake it. All handpicked by NASA, no regular Joes.
Well, no,
Right
I
on.
mean, the NASA astronauts, correct. I mean, they send regular Joes
Yeah, no,
up.
I'm sure we can trust the NASA
SpaceX launches.
astronauts that didn't sign an NDA or anything, or right?
Well, you're a civil servant, so there's no NDAs when you're doing that. There's you sign an agreement not to
Say what we don't want you to say.
Yeah, conflate your personal opinion with the stance of the government. So, it's not an NDA, but you are correct that there is paperwork that they sign that creates a level of censure.
So when one of them tells us they saw stars and the other one tells us they didn't, we can believe them, right?
Well, it just depends on what your eyes are focusing on at that point, right? The moon's really bright. Right? Like,
of course, because they all have different eyes and different heads while they're up there. I gotcha.
No, it just depends what you're looking at. Like, do you see the stars during the day?
They do have directly conflicting testimonies.
Yeah, that's fine.
Yeah, I'm not talking about Don Pettit. I'm talking about like NASA astronauts, like Apollo astronauts.
See, the issue you run into is that
directly conflicting each other's stories about when they were in
this
the daylight.
population is the one that only holds them to holds their comments to the same level as legal testimony, and they tend to speak pretty casually. So I'm not sure if they're
they have directly specific.
Oh, I understand that, but I'm saying
watching them talk about it, watching them give seminars directly contradicting each other.
Oh, I understand that,
like blatantly.
Yes, sure.
Okay, so why are they directly contradicting each other?
He's good with it. That's fine for him. No problem. Contradicting.
I mean, Josh is an expert at memorizing and regurgitating the book of bullshit, basically. And you could go, Flatman, you could go to university and become an expert at memorizing the bullshit like Josh does.
Hey,
but you're never going to be able to.
Stuff with us.
Oh, you don't. Yeah, come through and build some stuff with us. He says, how about you guys try to find some empirical evidence? Okay, hide behind your
we
NDA.
just don't
right?
think
You've never
highly
presented any evidence. In fact, you've been
not
caught
true.
out a whole bunch of times in here spouting absolute bullshit as if it's fact just because someone else told you that, like the Velcro thing, right?
Oh yeah,
The clip
no,
of
I've owned
you,
up for that. I
the clip of you
apologize for
with the
that.
Velcro thing, yeah. But the way you were talking about it, you sounded
Oh,
like
sure.
this was
Yeah, call
one
me
of
out. It's all
NASA's
good.
greatest achievements, and you were so confident, right? So you're wrong
Yeah,
about
it's fine.
that. Right,
Yeah,
you've
go
been
ahead.
wrong about other things. Great, you don't.
Sure, go ahead. That's fine. I'm
No.
not perfect. That's fine. I'm not perfect. Call me out when I make mistakes. Like I'm not gonna claim to be the authority on anything.
Yeah, I know, but
I'm just a dude,
the
man.
way you confidently
Oh yeah, I mean that's
bullshit,
the
right?
that's
And then you're wrong. You're just
that's
like,
the
oh
speech
yeah, I
and
was
debate.
wrong about that. No, I admit I was wrong, but I'm right about all the other things I say, for
Oh
sure.
no, I'm not. I'm not right about all the other things I say. It's the speech and debate stuff. Like I'm a customer facing dude, so I end up doing. The reason I haven't been in for a week is because I was in Taiwan working with the Taiwan Space Agency. It's actually my first day back in the office. But no, like I'm a.
Just shut your pie hole, but for fuck's sakes.
Wait, why? I'm sorry. What did I offend you? What did I do wrong?
So we now have very nice side view of a very, very well done laser test with a one of the best quality rectilinear lenses. Okay, we got a 6 mile laser test with a side view, right, showing
This is
that
FE core.
No, it's not FE core.
Oh, interesting.
Yeah, so I mean, so the laser's shot over 6 miles from 3 foot height. Okay, it's very clearly visible at the 3 foot target, right, at point C. Okay, so it's point A. Point B is a second station set up in the middle, directly in the middle, right to the side of the two. Okay, so it can get a side shot. He's used a pretty expensive camera. It's a $5,000 camera with one of the best rectilinear lenses, right, to mitigate lens distortion. And we've got a slightly over 8K 8K resolution side view of the laser transit. Okay, when we compress horizontally the 8K image, we don't see any downward bending of the laser, which would have to be happening if the Earth were a globe. Right. In fact, we see a tiny little bit of upward bending. Okay, because the weather station showed that there was just slightly warmer temperatures lower. Okay, getting a little bit cooler as you went up vertically. So you would expect a tiny little bit of upward refraction, which happened. But to be able to see the laser from 6 miles away at 3 foot height, and then to compress the 8K image with a rectilinear lens, right, and then not have any downward bending of the laser, that it would be impossible on a globe for that to happen.
I was gonna say, what's the diffraction of the laser? Do we have the angular rate?
We see the diffraction. Yeah, he has all of that in the documentary.
Or
right?
cones.
Yeah, but we can see that the laser barely diffracts, diverges. You're talking about divergence of the beam?
Yeah, beam divergence, but it's due to diffraction within the optics of the laser. So divergence is the effect, diffraction is the spec of the equipment.
Yeah, well, it's visible, right? So you could see how much the laser diffracts or diverges, essentially.
Yeah, I was gonna say,
so
is this in the side chat?
It's got next to it will be.
Hello.
Chanupa, welcome.
Hello.
Wait,
Welcome.
Flatman,
Hi.
I took some good pictures. I'll put them in the side chat. It was a good trip. Let's see.
Right.
I got to see Alex Honnold climb.
You can
climb
continue, okay?
101. It was a fun trip. They have good public transit over there.
You convinced me I'm on a spinning water ball since you work at a space
Yeah, that's
agency.
wonderful that they have
you.
good transit.
Oh yeah,
Such
the
great
bullet
news.
train was sick.
Yeah.
No, we're working.
Here's
We're
some
working on.
images. I need to.
Oh, go ahead. Sorry.
Oh, I was just putting those images in the side chat that I was talking about. That's all.
I appreciate it.
So yeah, this was done with weather stations, right? Measuring the temperature gradients, the vertical temperature gradients at point A, point B, and point C. Okay, we see that there's hardly any divergence of the beam as it travels over this distance. It's a pretty good laser. But what we can see, the main thing we can see, right? It's an 8K image, and when it's compressed vertically, right, for this to work on a globe, it would have to be seen bending downward. It would have to be curving with the curvature of the Earth. The fact that it's bending upward at all, okay, shows that there is no downward refraction, right? It's not possible on a globe. Right, if you have a situation where you don't have the downward refraction, okay, you've got upward refraction, and the laser is also being seen at. Yeah, I do have the primary source.
I was going to say, would love to read. I appreciate the candor. And I was going to say, Flatman Can, if you want to learn about the B5G satellite constellation, let me know. That's what we were working on over in Taiwan. Building a resilient communication system for the island when the PRC cuts the undersea cables.
Yo, DJ.
Hey. What's up?
Hey DJ, that last guy, is he still here or is he gone? The satellite guy.
I was going to say,
Josh?
I'm here. I'm in the office though, so I'm bouncing between folks.
I didn't hear the
I'm
conversation, but did you sort of provide any like sort of direct evidence for the idea that we live on a spinning curving surface, or was it just about you?
Oh, I was going to say, I got some stuff in my profile if you want to check it out. There's some links there, but I've posted stuff in here before. I've been hanging around for, I don't know, 6 months now.
So I'm not at the computer actually. I'm away from the computer. But what sort of things have you got then in terms of direct evidence? Because obviously a feed into your job, doesn't.
Yeah. Uncut rocket footage. There's some papers written on external pressure sensors at the ISS showing that it's not in a perfect vacuum. Usually my go-tos are, especially the questions coming up of, is there a container? Is there not? Is pointing towards standard atmospheric models that were created in the 1970s using high altitude weather balloons. So,
right, but the weather balloons can only go up to a certain height, right? And then it has to be modeled on a computer above that height. So you can't even get a reading in the mesosphere.
Well, that's what I'm saying. Like you have the pressure. There's a certain area where any measurements that are made require the Earth to be a globe or for orbital mechanics to work. So you throw them out. So the reason I say weather balloons is because that's about as high altitude as I can go without you instantly saying that it's fake or not true.
No, not saying that it's fake. Saying that you can't actually take a barometer and make it work above a certain height. Okay,
You don't
not possible.
use a barometer.
And
use
even meteorologists have come in here Well, meteorologists have come in here and said, yeah, we don't know what the pressure is above a certain height, other than that of what a computer model is telling us, right? Because we can't even check at 50 kilometers height. Okay, well, they have to make a whole bunch of assumptions when they're using the different methodologies.
Well, you have both dynamic and static pressure on launch vehicles using piezoelectrics. So it's like, once again, you have to appeal to the tech that we're using to assert, the
and
model
when you
that we
dig
live
into
in.
when you dig into it, right? It's not as it seems. It's not the same as taking a barometer or anything like that. Right,
Well,
and most of the time it's computer. It's just modeled. It's modeled on a computer. It's not. It's not a direct measurement.
On launch vehicles, no, that's not true. We have piezoelectrics for both static and dynamic pressure. You put one parallel to the flow and one perpendicular to the flow, so you're able to understand how much of the pressure is due to your velocity and how much of it isn't. So, no, I mean we have direct data higher than weather balloons, but once again, it requires taking measurements from tech that you say is part of the cover up, so it's not reliable.
Well, this is the thing, right? None of us can empirically validate any of that, and that's all of your evidence is basically faith based, unfortunately, and we can directly contradict. Well, it essentially is. I mean,
fundamentally is.
You can never empirically test anything that you're telling us. Okay, you just have to believe the numbers that you're getting.
No, that's not true. I mean, we got 180 satellites up right now. I've got what's that times 4? 720 my optical terminals like that.
What's the initial collection point for the data?
It's AWS.
No, the initial collection point for the data, like which terminal?
And we have hundreds all over the world.
Yeah,
so there's an array of. Oh, I understand. It's all of them. There's hundreds of. They're called gateway arrays. So they're basically complexes with 6 2.4 meter antennas that we use to track each of the spacecraft to get data down. So there's, like I said, they're spread out all over the Earth.
Yeah, can you provide an example of such a place? Maybe 2 or 3. Can you show us?
Oh, sure. Yeah, I was going to say, where are you? Let's see.
I want to point out the funny thing. 3 months ago, Josh didn't know any of this shit, but was saying the same thing he's saying now. He didn't know anything about how any of the communication was done, how the pressure measurements were done. You didn't know about any of that. But now
I'm learning.
You do know. How is that?
Oh, well, I'm learning.
I told you some
I'm learning.
And you were like, I believe it.
No, I worked within a large organization and collaborating with folks.
Josh, you didn't know any of this 3 months ago because we talked about it. We all asked you about it. And you just
no.
about the mesosphere when you talked to AB about that shit fucking 3 months ago.
And you told us that you could go talk to a guy who could get you the information, but it turned out to be a company name instead of a guy.
I don't recall what you're referring to there.
Man, it began with a B. What was it?
Boris, you don't recall what happened 3 months ago.
Yeah.
You remember?
Okay, I'm telling you.
You don't remember what I'm talking about.
We've talked about this stuff many times, Josh. Everything you just said, you never said before.
I understand that.
The last time I heard you yap, which was 3 months ago, and now somehow you learned the information because you didn't know it 3 months ago.
Hey, we're not static, man.
That's right. It was a device component that began with a B that you thought was a company name.
I don't recall that. I apologize.
Yeah, it had to deal exactly with the pressure sensor we're talking about.
Are we talking about the ISS pressure sensor? Or are we talking about launch vehicle pressure sensors?
No, it was an ISS pressure sensor that you said that you could go call this company and go get the guy and provide the information. And I looked it up, and it wasn't a company. It was a device component name that was not like a proprietary brand name or anything.
Oh, interesting. I don't think that was a conversation we directly had.
Yeah, it was you and I directly had this actually. It was about 3 months ago. It was on a Thursday night actually, and Indio was here. And then after you left is when we figured it out.
Oh, okay, yeah. So that's new information to me then.
Bill just bringing out his inner Rain Man. Knows the date. What the fuck, bro?
Yeah, I could actually start to pinpoint it.
That's fine. Yeah, I was gonna say, like, if there was more stuff y'all figured out after I left, that I'm happy to discuss.
I know, but it was an integrity issue for me, man. So that's why.
Oh yeah. No, I mean, honestly, that's not my bread and butter. I'm out on a limb there. But the question that I was trying to answer was, what is the external pressure of the space station? So, we tried to hunt down what the hardware was and some of the sensor names, etc. So it's not, I'm not going to claim that it's my day to day. Like I do space lasers. That's my shit.
You sound like Dr. Evil or whatever the dude's name is.
Yeah. No, honestly, like sometimes I just take a step back. I was talking to somebody the other day, and they're like, and I'm in charge of like headcount and budget and product roadmap and all that jazz. And so sometimes I need to like take a step back and realize that we're actually working on space lasers. It's still white collar work. It's not like anything crazy.
Groundbreaking. Space lasers. That's really going to improve life down here on Earth for us. Groundbreaking work there, Josh.
No, it's like fiber optic cables without the cable. It allows you to move data.
Is building a space laser blue collar or is that white collar?
It's white collar. Oh, building it? Like the actual technicians? I don't think so. I mean, it's
blue collar because the way you refer to, you mean the technicians? Like, yeah, the losers that actually build it, those losers.
No. I'm trying to think because it's like it's engineers for the first couple units, and then once we design for manufacture and scale up, it switches over to technicians. So it depends on the scale of the hardware you're building, I guess. But no. I guess that's true with any hardware, though, right? Like the first people design the first unit.
What are you budgeting then? If like, you don't know like the actual manufacturing costs.
Oh, we're not at scale yet. We're still R&D with
physically building the instruments you think exist.
That's the commercial team. They
Gosh,
have 780 up already.
So basically, your knowledge of everything
or 720.
is reading a screen or some pieces of paper.
No, I was in LA. LA earlier this week, getting up to speed.
I'm just saying, occasionally you see videos of a rocket, and they're like, "We pinky promised there's something on that you talked about, Josh. We promised we put it on there."
No, we're getting live data down with the performance of each of the subsystems that were designed. Like and
I'm just trying to figure out how many what do they call it? How many steps removed are you from the actual physical frickin' object that must exist in the real world?
One, I'd say.
Shades of Kevin Bacon or something? How many shades of Kevin Bacon are you away from?
I was gonna say it's one.
Within screwing a screw into something?
Yeah, 100% one. My lead engineer is the one doing most of that work, and he's the one that reports directly to me.
Manufacturing
it? Correct. Yeah, we're doing so we're doing a delta off of the design that's already up in space. So it's
okay. The guy, your lead engineer, is he putting screws and shit?
Yes.
So he's physically building it. He's a technician. One of these techs you talked about.
No, once it gets to scale, he'll pass it off. But right now, it's him.
Oh, so it's a one-man job. He's just
no. We have a team of like 20, but he's in charge of that team, and it's engineers for low scale when we're doing initial design work, initial testing, and then once we get a unit that works correctly, you scale it up, design for manufacturing, you outsource a lot of the components, and then instead of building 2 of these things a year, you build 20 or 200, and then that's where you get on like the automation line, etc.
Sounds like concept prototyping. Then is that right?
Yeah, that's what sounds like to me.
Well, so what we're doing is, and this is all public info, but we're taking the Leo constellation is going to be about 3,200 satellites. We got 180 up. Each one of them has 4 laser comm terminals on them to create like a mesh network in low Earth orbit around 630 kilometers up. And so each of the satellites has 100 gigabits laser that communicates with the 4 satellites that are next to it. And so what we're working on is taking those laser terminals, repackaging it with some extra electronics so that we can sell it to third-party satellites. So like space stations, Earth observation satellites, other folks, so that instead of having to use those RF ground stations to get their data down, they can use the laser to link into the mesh and then move the data through the Amazon network. So like kind of like Google Earth, but live, right? Like eventually, where instead of having to wait, take a picture and then wait until you're over a ground station to downlink the data, you take the picture and you're already connected via the laser, so that you can move it down into AWS as you're taking it like live almost. So that's the
Optical
end goal.
uplink downlink. You're talking.
No. Still RF uplink downlink.
Groundbreaking. So you seem to know a lot about this Artemis stuff there, Josh. Do you think if Artemis is oh, go ahead.
Yeah, just hold on a second. What he says they're creating is a mesh network in space. So when
Correct.
you shoot, so when you want to talk to, say, Tokyo from Los Angeles, you communicate with the satellite that's over you. It sends a laser to the satellite over Tokyo. I'm just saying, don't.
Yeah. There's more hops, but yeah.
It's gonna be 3 or 4 hops. Yeah, I know that. I'm just saying that conceptually. So it's going to shoot a laser over to a satellite to Tokyo, which is going to downlink there, right?
Correct.
That's the idea. Okay.
Correct. And that up and downlink is via RF still. It's Ka band.
Yeah, it's very ambitious, and good fucking luck, bro.
Yeah,
Well, I mean,
give me
we're
a
already
dip angle correction for that link.
Because especially when you said 3,600 satellites, let's add that to the 40,000 they say is already up there. You know what the Kessler syndrome is, right?
Correct. That's something we care about a ton. Actually, SpaceX announced this morning something called START. Oh, go ahead. Sorry.
They're going to turn that off like a water spigot. They're going to just go, oh, the Kessler syndrome thing happened. We're shut that off like a water spigot. And they don't have to tell no more space bullshit stories. You want our job.
No, you can empirically. I was going to say you can empirically check if they're what is actually happening, because all debris that's over 10 centimeters in diameter is trackable from the ground, either via
that's nonsense.
radar.
Their own words. Listen, they used to say that shit when I was a kid. They could track stuff the size of a pen in fucking orbit, bro. Their own words.
I just said larger than 10 centimeters.
Josh, they double speak on that, because they'll
disagree.
also say when you're talking about foreign countries and their capabilities, well, we can't. Some secret satellite could pull up to one of our satellites and throw it off orbit, and like, well, if they're tracking shit the size of a pencil, how are they going to do that?
You're talking about 2 different orbits. One is, the co-orbital anti-satellite weapons are operating out in GEO, which is 36,000 kilometers away, versus LEO, where we're actually tracking things for Kessler, is, I don't know, like 400 to 1,000 kilometers up. So you're talking about an, order of magnitude difference there, which is why you have lower resolution.
Double speak on that. There's no doubt about it. I've been watching them do it.
Ignoring nuance. Interpret it as double speak.
Not ignoring nuance.
I disagree.
They say out of one side of their mouth that all this sneaky shit's happening in space, and then out of the other side of their mouth, they say they track everything.
Well, yeah, you can track everything and still be sneaky, right? Like there's Russian assets that have deployed, sub-satellite systems. It looks like a projectile being ejected, right? You can see that the projectile's there, but you don't know what it is. And tracking something that is 10 centimeters or larger doesn't mean that you know like what the shape of it is, or what it's meant to be able to do, what assets it has on it. So like knowing something's there and knowing what that thing is are two separate things.
Yeah, we already know Josh is okay with them having conflicting statements. I wanted to get you on record, Josh. I wanted to get you on record. I wanted to ask you a question. If you think Artemis 2's happening in a couple weeks. If that's successful, I just want to get you on record. Do you think they'll have the new moon bases up there within 9 years after Artemis lands on the moon in a couple weeks?
Probably not. It's not landing on the moon. It's doing a free return trajectory on the far side.
Oh, sorry. Oh, fuck, shit. I thought we were going back and finally putting someone on the moon again. We're not doing
that's 3. That's Artemis 3.
So we're not doing. Okay, gotcha. We're still just wasting money. Still, okay, gotcha.
Well, no, you're testing the crude capability of the capsule outside of low Earth orbit, right?
Actually, no, we're getting a lot of CGI bullshit images and lies, but okay, you
I
got
want to hear
yours.
more about their tracking of these space objects, because listen, I remember NASA's Deep Space Network says that their electro-optical arrays can track a basketball 25,000 miles away.
Well, yeah, that's DSN versus like Leo Labs or other commercial tracking, right? Right. That's again ignoring nuance.
And you believe that?
Once again, knowing something's there, and DSN is not for radar ranging; it's for radio astronomy, right? So, if there's a difference between like a ball of lead the size of a basketball and like a radio transmitting at X, decibels in a frequency that the antenna is tuned to. So, knowing something's there once again, there's a lot more nuance. You can't just say yes or no.
Of course he believes it. He's paid by a space agency to believe it.
I'm not paid by a space agency. I'm paid by Amazon. Yeah, I can show you my pay stub if you'd like.
I'm sorry, I'm just so confused, Josh. I thought you worked with the Taiwan Space Agency and all these other space agencies.
International business development.
So you're getting paid by somebody to do some space stuff. Gotcha.
Correct. Yes, I am in charge of some of our civil space.
So yeah,
accounts.
Of course you're gonna spew the bullshit and believe it. Of course.
I mean, honestly, I was telling my coworker that I do the work for Taiwan for free. Like, I care more about providing them the capability than landing any contract or doing any specific work.
Thanks so much. What a contribution to mankind. Thanks, Josh.
What, providing the Taiwanese people a resilient communication system once the PRC cuts the undersea cables? Like, I don't think the sarcasm is warranted there. Having access to utilities, emergency services.
Yeah, great. I know. I was just thanking you. I was just thanking you. That's all. Thanks, Josh.
Okay. Back away from the sarcasm, I guess. But like, I appreciate that.
Josh, how would you go about the idea of proving that we live on a spinning ball without appealing to the data from these space agencies? Is there a real world observation, or is there anything that could resemble a spinning ball Earth in reality that we can look at?
I think my stance on sort of where the bar is held with this community as far as like what evidence is credible, that there is no, like, it's kind of like a Venn diagram, but the circles don't overlap at all. So like the quality of the evidence and the source of the evidence is like two separate circles.
No,
so at least that's just my thesis on my understanding of this group.
The only evidence we'd need would be a measurement of a rate of change of slope over a distance of the Earth.
Correct.
That's the only
thing. You have to be far enough away. I think the distance away from the Earth you have to be to observe that requires once again the technology that you claim is CGI. So I don't think there's any overlap between the source and the quality of the evidence that would be able to convince this group that we live on a globe.
that evidence, whether it's CGI or not, shows the Earth to be a sphere, which should be measurable on the surface.
Well, I guess there's one more nuance to my thesis here is that I don't believe that within the medium or at human scale that you can observe that curvature.
A spacewalk's going to be required.
The scale.
Yeah. Earth's too big. We're too small. You can't see it. I don't think the parametric equation of 8 inches per mile squared is applicable.
Okay, so not see it, measure it. And 10 miles, we should, according to the curvature rate of the Earth, we should be able to measure that because that's where it is. And you're saying we can't measure on the surface of the Earth.
Within the medium, correct.
So we can't measure anything on the surface of the Earth using any type of frequency, whether it be visible spectrum, radio, for example.
Once again. I don't have a ton that's India was saying I came back and knew more things outside of my conversations in here. I'm trying to answer these questions for myself. And once again, that's just my working thesis is that within the medium at human scale, it's not observable. And I'm trying to figure out why.
Okay.
No,
so my supposition, right. So your supposition is it's not measurable. You don't see it, or no, not measurable. You measure it as flat, therefore all the other data must be false, right? The space agencies, the satellites, et cetera. I'm sort of backwards from you. I see all of that, and I have firsthand experience of that being how the world works and how these assets work. So I'm trying to figure out, why these local measurements are lining up the way they are.
This is the difference, though. All of our tests, right, are empirical. Anyone can go and validate what we're showing people, and we've got a countless amount of them now. Okay, and zero of the information that you're telling us is able to be validated empirically.
From an individual human, correct. You do need a certain level of capital and access. I agree.
No, but you would have to actually go into a place that we can't validate, right? And a place that you can't prove to exist other than faith. No, you
can launch a camera. Yes, you can.
Really? You can launch a camera up to what height? Up to what height can you launch a camera?
Wherever you can get a ride share, right? So 1,000 kilometers.
Right. So you have to hand the camera over to SpaceX.
You're not handing over your encryption, right? You're not handing over your encryption key. So your encryption key works, and you're getting your data down from the sensor. That is the object that you launched. I don't buy into this quote unquote chain of command fallacy that says that the instant that you hand your hardware over, it's no longer credible that it's actually your hardware anymore. There's other ways to verify that.
Exactly. That's the thing that you choose to believe. That you choose to believe that it is still your hardware. You don't think that it might be just direction of not a video that is being captured by the camera, but something that have been made in a simulator or a 3D program like an animation. And because you believe that
your encryption, right? That's not how that works.
Yeah,
that's not how that works. I apologize.
It is how it works. You chose to believe that it is the footage from your.
You don't hand over the encryption key. You don't hand over the encryption key. You don't hand over, the actual, specific specs of your sensor. You could draw a smiley face and Sharpie on the lens. Whatever data you need to prove to yourself that is your asset. There's levels to this that cannot be broken by a chain of command. Or chain of custody. Sorry.
Of course, Josh.
Okay.
Yeah. They would never betray anyone's trust, would they? I mean, look.
I didn't realize that we could crack a AES 256 encryption just by handing it over.
This is the problem. The amount of satellites that you're saying
in front of a large screen. So you still use your camera, but it's not the Earth from space. You're just watching.
No, because you know exactly the TT&C spectrum that your radio is broadcasting on. You know exactly where in the sky it is due to orbital mechanics. That is your satellite.
Which footage? Who did what you're saying? Okay,
it's all Planet Labs. It's almost every single satellite. I've posted stuff from Leo before, and you guys.
There isn't a photograph of a satellite in space. And you even yourself said that they use fisheye lenses, right? And they're too cheap to get a rectilinear lens. And you've tried to address that with them.
Oh god. No, I mean,
I'm just asking you to present some evidence, right? That's all. So we have something to actually go over, rather than there's all of this evidence.
Of a satellite in space? Let's see. Like, what are we looking for?
What you claimed. You said there's camera footage, video camera footage, right? You said anyone can just hitch a ride, strap a camera onto these cameras. Yeah. So who did that? Show us the footage.
What organization would you prefer? If I show you a college versus
Okay, so you said you've got what you claimed, right? So pick the best one and then just chuck it in the sideshow so we can have a look at it. I'm not saying you're wrong. I'm saying, if you want to come in here and make claims, we'd like to have a look at what you're talking about so we can analyze it and see, if we have any questions about it. I'm not just going to present something and just say, trust me, you can go look it up yourself. You could go find it yourself, right? If I present something, I'll have it.
I was going to say, here's a picture of a Chinese spy satellite taken from orbit above it by Maxar satellite. This is over the summer, I think. Yeah, last June. Let's see what else we got.
Okay, so we don't even see so we're talking about Earth curvature right now.
Right? Okay. You asked for an imagery of a satellite. Okay, that's fine. That's why I was trying to be specific.
Okay, yeah. I mean, how can I validate what I'm looking at here, the altitude and everything, right? How am I able to validate that?
Oh no, that's fine. I appreciate the correction. I was just trying to figure out what you actually wanted.
Well, what you said is you can. Okay, so we were talking about. You can't.
That's a Maxar satellite.
Okay, so you said you can just send a. Why don't you just send a camera up?
So that is a camera up.
Oh yeah, okay. So what height is it? How can we validate that? We don't even see the Earth. We're talking about Earth curvature, and you were saying, to see the Earth, the curvature of the Earth, you would have to go up past a certain height. No, you said this. Okay, why don't you just put a satellite on a government rocket? Right, just like it's just easy. Just go do that. Go put a satellite on a government rocket, hitch a ride up, and you can see the curvature of the Earth for yourself. And then I was asking you if you could present that, who did that, and can we have a look at the footage? Because it must have been done dozens of times, right? So find us some civilian footage where they strapped a camera on to the NASA or whatever rocket, right? And they filmed the curvature of the Earth. Okay, then we want to know what type of lens was used, how we can validate this, whose equipment was it.
Well, I'll give you one more. So the two I just posted were from one of our LEO satellites. Here is TechEdSat 8 deployment.
Okay, let's just stick with the first one. Okay, what's the altitude?
630.
630 miles?
Kilometers. Sorry, I don't do
630
imperial.
Kilometers. Okay, what type of camera is this? What type of camera is it?
Not at liberty to say. I apologize.
I'll see. There we go. Wow. So anyone can just do it. Yeah. And then you show a footage.
Oh no, I'm trying to find.
I asked you what type of camera was it. It could just be a wide angle lens, and we can't really validate. So this is just all trust me, bro. That's what I'm saying. With you, it's always just trust me, bro. Whereas you can go and validate anything that we're telling you, but the camera's a secret. What's the focal length of the camera? Is that a secret too?
Yeah. Once again, that's not. I'm not at liberty to say.
Or you really see that's why.
No, it's fine.
That's why people aren't going to take you seriously when you come in here, because what's even the point of sharing this? Okay, you were saying that anyone can just strap a camera up. Anyone can just strap a camera, hitch a ride, and film footage, right? And I asked you, okay, who did that?
Yeah,
show me footage, and then you show me a picture, and you can't even tell me what camera was used, right? So
I understand that. I'm grabbing
all of this
not
footage.
Proprietary. I was going to say that's the stuff I'm physically working on.
You're making claims like anyone can just send a camera up, see it for yourself. I'm like, okay, who did that? Yeah. Can you provide me with the information of someone that did that? And you can't do it, right? Now all of a sudden you've just sent me a random picture that's completely faith-based. You can't even tell me what camera was used or the focal length or anything.
I was gonna say that's
Josh,
my own company, not public data.
Josh, look in the side track. There's a unicorn there. Nice photo, eh?
Sure.
Yeah. So now, do you believe that unicorns exist?
Oh no.
Because you saw it in a picture, in a photo. We have
Not
videos
taking
too
anything I
about
find on Discord of
unicorn.
this. Like,
Yeah, and I can also share with you some testimonies from some people claiming that those unicorns exist. Exactly the same evidences that you have about the
that's
globe.
fine.
You don't have anything other than that. It's just a bunch of images.
Yeah, exactly. Look, Josh, you said, why don't you just send a camera up, right?
If you'd like to, I'm happy to work on you.
Okay, so who did that? Right? Who did it and post what they did? Right? You made out like, oh, just look it up yourself. You could just go and Google it and find all of these different ones, right? And then I asked you to post your best one. Your best
working on it right now.
Your best one was something that you couldn't tell me any information about.
No, it's not my best one. That's the one. That's the one I'm.
Okay, so when I asked you to post your best one, you didn't post it. I want a video.
Hey! I'm trying to find some stuff right now. I apologize. It's hard. Can't really talk and
make it a video
talk
too, dude. We want a video.
Okay, that's fine.
Yeah.
Sure. It's hard for me to talk and Google at the same time. So I appreciate the candor. I apologize. I was grabbing
really
something directly out of my.
We appreciate the content,
camera roll.
It's good.
I just look at the video that I just sent, DJ, and see if you will just believe other videos from those space agencies, because it's proven that they fake things.
I started laughing in the background whilst I was sorting my fire out. DJ was like, wasn't going to let it go. You said this stuff
fine.
that you're going. Oh, no, I wasn't talking to you. You said you found it difficult to do two things at once. Yeah, that made me laugh.
What you said, Josh, was it's very easy for a civilian to send up their own personal equipment, strap it to a rocket, right? Hitch a ride, and then film the Earth and see the curvature of the Earth yourself from space. You made out like it was simple, and many people had done that. Okay, so that's what I'm expecting from you. And if you don't have it, if you can't find it, we're going to need a concession.
Guys, it's hard for me to talk and Google for my best proof at the same time, guys.
I think you're overestimating your importance of your community to
yeah. So that's just an ad hom. Just
no. Just saying. That's why I don't have it readily available. That's why I'm like,
just
I apologize.
Yeah, I forgive you.
I thought it was a globe, but I was wrong.
Okay.
Quara Tata, are you listening or are you hot micing a little bit?
It's been like that for a while.
Yeah, I'm going to just pop him on mute just in case he's sleeping or something.
Honestly, I think that's one of my biggest fears because I would love to fall asleep listening to the chatter either in here or some of the other rooms. But yeah, I'm always afraid that after I pass out, I'm on a hot mic.
Just make sure you're muted.
Well,
Josh,
there's like weird stuff with there. Oh, go ahead.
I was following the conversation. I've been listening in the background. What was the conclusion you came to when Jedi asked you about the measurement of the drop over distance?
Once again, I don't think it's measurable.
Yeah, but like you said observable, so now you've said it's not measurable.
Oh, apologies for the semantics there. Yeah, I don't think it's observable.
If I recall from the conversation, he said he doesn't believe in the 8 inches per mile squared, and that Earth's too big to see or measure the curve.
Well, he can't change the
Is that
size.
right, John?
You can't change the size of the Earth. You can't do that. It needs to be there or thereabouts that size, right? You
Oh,
agree?
come on, y'all. Hills don't exist. There's no drop over distance.
Who's this drunk guy?
That's P drinker.
Trolling.
I just want to know your position, Josh. So is it your position that the 8 inch per mile squared is not measurable in any way, shape, or form?
Well, I just don't think that it's a good parametric equation for long-term observations. I think it's an easy sort of
No. That's the geometry over these distances that we're talking about. That's the physical geometry matches up.
It's a parabola. It's not.
No.
Parabola
Over
and
the distances,
separate.
Josh. Over the distances that we're doing the observations, such as 20 miles, 30 miles, for example, it's perfectly accurate. Okay, but the results are off by orders of magnitude. Okay, so even if it's not perfect to the point, it's close enough that there would be approximately 266 foot of curvature over 20 miles, for example. Okay, that formula works just fine for that. Okay, if you could use any other formula you like, it's going to be approximately 266 feet over 6 miles over any 20-mile body of water anywhere on the Earth. Right? And every single time we go and test that distance, there's zero curvature. Even if we account for the meteorological conditions to the best of anyone's ability, using weather stations, using infrared cameras, using lasers, getting side views, right? Showing you that there's no bending of the laser with a side view, okay? Or accounting, right, for the vertical refractive index or the vertical temperature gradient, right? At minimum, to eliminate the possibility of these extreme conditions that would have to make it work on a globe. Right? This is testable, repeatable. This has been done over and over again. We can tell you exactly what camera was used. We can tell you all of the information. I don't have to say, oh, that's a secret, like you do with your images.
I apologize for that. There definitely is access.
Oh yeah. You will be. Yeah. Look, dude, I apologize for that. That's such a ridiculous response. But look, this is the thing. Okay, you don't know anything about optics. You don't know anything about optics, right? You could easily just look into it. Well, you don't know anything about. You don't seem to ever come back with any new information about it, other than just handwave dismissing it all and saying.
I mean, FE Core didn't post their actual diffraction of the laser. Like they only posted the accuracy of the apparatus.
It hit the target though, right? It hit the target on every single test.
Yeah, but you don't know you don't know how far the laser has spread over that distance, so you can't, quote unquote hit doesn't mean it's the center of the beam.
You can see it on the target, man. It's like 3 feet wide.
Yes. I understand that. At that distance, it should be greater than 10 feet wide. I mean, happy to actually, I'm not at a point where I'm willing to sort of put a line in the sand and say this is how things are, but the claim that I'm not actually looking at these things outside of these chats is inaccurate.
I posted you literally an image of a side view of a 6 mile laser test.
Oh, I asked for the primary source.
You can. Yeah, I did. I sent you the primary source.
Exactly. I'll take a look at it after the chat.
Yeah, but you can see that the beam isn't diverging much over that 6 miles, right? You can literally see the entirety of the transit.
So look at it later. He's too busy Googling for his best evidence of Earth curvature. He can't look at that right now.
Specifically from a CubeSat, I'm trying to find. Like I have like I said, the overlap between evidence that's acceptable and sources that are acceptable is very slim to non-existent.
You said a civilian can just hitch a ride, strap a camera on, hitch a ride, and video the Earth as a globe. And that's all you had to come up with. You said it would be, pretty simple to do.
I was going to say I have to usually go through conference proceedings or go look at university websites once again. I have stuff.
We could give you 24, 48 hours if you need it, Josh.
That's fine. More than yeah, whatever you like. I mean, I'm not holding myself to a specific timeline here. I'd like to get it done now. I have a call at 11.
Yeah,
but
it would be good if
I
you
mean,
could
like,
get it done
don't
now.
hurry or anything.
But like at the end of the day, it gets back to the whole purpose of my interaction with this community is not to convince anybody.
I got a question.
Yeah, obviously you're not going to do that.
You won't. You won't.
That's fine.
People
That's
here
fine.
don't go.
I'm
don't
okay with
go
that.
Like I told you, everything that you have that you can propose to us as an evidence that you consider for yourself being your standard of evidence, which is just ironic. Photos, videos, and testimonies, and data, also data that you can't validate this its source. It's just that.
Exactly.
I
Once
believe-
again, that's why I'm saying there's no overlap between the quality and the source of evidence in here. So therefore, based on that conclusion, my concession is that my purpose here is not to convince anybody. It's more to understand y'all's worldview.
But do you understand?
We
Do
don't
you
care about-
understand the standard that we're looking for is a measurement, right? And when Dietmar said
Correct.
over 20 miles is 266 feet, you're talking about something nearly as high as an elevation change, nearly as high as the Statue of Liberty.
Yeah, that's
Okay,
the
so-
quality evidence circle.
Yeah,
Is
but your claim is that there is absolutely no way to measure this. Now, I understand why you're saying that because that's the rhetoric, right? But logically, 266 feet drop in elevation would mean anything like an oil rig or something like an island at 20 miles should not be visible. And if it is visible, there isn't enough refraction in the atmosphere to be able to account for that. So why do you act like our worldview is so strange and crazy when this is a very hyperlogical
it's not
question?
strange or crazy. Yeah, no, it's not strange or crazy, but it's.
But why do
it's,
you not
know,
understand? Why do you not understand that this is something that should be measured, should be able to be measured in terms of drop over distance?
I agree. That's why we said before it's the inverse, right? So I have firsthand experience of data that shows the Earth is a globe. So I'm trying to figure out why those long distance measurements don't line up. It's the inverse of why, you look at the data from the long distance observations and then by conclusion everything else must be a lie and must be fake and CGI, etc. So it's the inverse sort of endeavor that y'all are on.
So you do understand the concern, and you're trying to figure this out for yourself as well.
Correct.
Okay. And do you not think that you're slightly biased just because of the nature of the work that you're doing?
Oh, I think
you're not able to confirm satellites are going into a vacuum in the sky, right?
I am correct.
Not really.
Are you still
because
Googling?
You're using modeling. You're using data and then modeling that data to be able to present something. You're not actually providing evidence.
I mean, if you take a picture of something that's across the room, is it still there, right? Like you're just putting a camera up or a radio in longer distance. So once again, it gets back to the chain of custody thing. It's all good.
Yeah. Are you still Googling for this amateur footage that's...
Honestly, it's going in circles a little bit here as far as being able to actually go look at conference proceedings. Because I have stuff from Maxar and stuff from other commercial entities, but once again, the quality of evidence versus the source of the evidence, I think there's a very narrow gap here, which will actually be a productive conversation to have with y'all.
Well, this was simply your claim. I mean, you said,
no, I agree.
Why don't you just send a camera up? You could just hitch a ride, and it's very easy to do such a thing. And you said that people have done that. So
he forgot what he was doing
entities.
in 5-10 minutes. He forgot what he was doing in 5-10 minutes talking with us. Yet he's working on space stuff. Wow.
Just disagree with that. No, I'm saying that I found commercial organizations that have a decent amount of capital that are doing it. I'm trying to lower that capital restriction to find evidence that would support my actual claim.
From a regular person.
Yeah,
correct.
Just a civilian, that's all. Like you said. I mean,
yeah, exactly.
So, yeah.
No, agreed. Exactly. I am a bit biased as I work with organizations that have, eight, 9 figures of capital to sort of expend. So I'm trying to find a university lab that's working with, 6 or 7 figs, able to do the same thing. Oh, Lordy.
I got a question for you, Josh.
¿Qué pasa?
Have you ever used the 8 inches per mile squared math and compared it to like a Earth curve calculator and see if it lines up?
Or like a geoid model, right? Because it's a
Just
function
an
of
Earth curve
what azimuth you're
just an
pointing
Earth curve
towards.
calculator.
No, I have not.
Yeah, like Earth curve calculator uses the geometry of the Earth that uses the radius as an inference. Doesn't even use 8 inches per mile squared. But yeah, give it a shot, man. Like, do an observation, make it like, let's say, 100 miles, and make the observer height like something dumb, like 10 feet. Just simplify it for number reasons, and then
I guess
use 1.225 times the square root of the observer's height in feet. You can put that to find the distance to the horizon. You subtract that distance from the total observation, and then that number you make 8 inches per mile squared, and that'll give you your hidden height. It works every time.
Yeah, I agree. I'm just saying I haven't actually done the exercise in a while. It's been a few years.
So you have done 8 inches per mile squared.
Yeah, I'm recalling I got into a conversation on Clubhouse in like 2022-ish, where I didn't think that the horizon for a 6-foot observer should be about 3 miles. That didn't make sense to me, so I actually ran the numbers.
Yeah, that one's easy. All you got to do is 1.225 times the square root of the observer's height in feet. So 1.225 times the square root of 6, and that'll give you your distance to the horizon, approximately.
Yeah, agreed. Remembering that it was a few years ago, I got climbed on because I fucked up a decimal.
Let's say it's a 10-mile observation. You got 3 miles to the horizon. You got 7 miles to the remainder of the object. So you do 8 inches per mile squared. So 8 inches times 7 squared, and that'll give you your obstructed height. It works, dude. To say that it doesn't work, like that's
no. I'm just saying the parametric, like a parabola, is not the same thing as a hemisphere. So there's only certain distances.
But it's good up to like 1,200 miles, or yeah, it's good up to 1,200 miles. So like, I don't understand why.
Exactly. Exactly. It's a parametric that's easier to work with.
Yeah, everybody knows that already, and you know that we know that. Okay, we're saying that over an observation of, say, 10 miles or 20 miles, that's going to give you the correct answer for how much drop over distance there would be.
Yeah,
sure. That's fine.
Your contention was the formula. And we've all agreed that, yeah, it's parabolic. It's not useful over distances of, let's say, over 1,000 miles. But we all know that we're observing less than that. So being as we all agree on that, is it fine?
That's fine. We can throw it out. That's fine.
So at the beginning, we thought it was a problem, but now we reached an agreement that it's fine.
For specific distances, correct. It's just not something you can just throw out without capturing the nuance.
Even at 1,000 miles, what's the difference between you and I? At like, let's say 8 inches per mile squared gives me an obstructed height at 1,000 miles of 124 miles, but the Globe Earth calculator says 122.8 miles. Like, what's a mile 0.2 between you and I at 120 miles?
That's fine. I'm not disputing that. I'm just disputing when it's used without, also claiming that it's a parametric and it doesn't, the map is not the territory type of deal. That's fine. I'm okay with it actually being used.
You included it and dismissed it in the same fucking sentence.
So we can use
exactly.
it. So
yes,
we can
as long as you, that's fine. Use it. Just note that it's a parametric.
Yeah, we do.
So that's fine. That was the initial contention earlier. It wasn't being.
So then the equation is perfectly fine then.
As long as it's denoted to be a parametric, that's fine.
Which it is. So
it is. Okay, we're good.
So no, you're good, right? This was your contention. So being as we point this out because we're doing it, we point it out straight away. That there shouldn't be much of a contention. You can use other formulas, but they're still good to note. A rate of change of slope over, let's call it local distances, 10, 20, 30, 40, 50 miles. Right?
That's fine.
Cool. So we don't measure that.
Exactly.
Yeah, the equation says we should because it's a rate of change of slope or whatever denotation, but we don't measure that. Why?
Yeah. I don't know. I'm trying to figure that out.
No, it's because it's not there.
I'm interested. I'm interested as to why. One thing that like I said, I've been thinking about this stuff for a while.
I'm trying to figure something out, man. You're like, oh, it's a parametric, so it doesn't really equivalent to actual Earth curve. But yet you'll accept 2 fucking stick shadows or a stick in a well, 500 stadia apart as evidence for fucking Earth curve measurement.
Josh, I hope you're still looking for that footage. I hope you're still looking for that footage, brother.
Currently restarting my computer, but yeah. 8% of the way there with a Windows update. Happy to send a picture if y'all think that I'm, pulling shit out of my ass, but no, I guess the one thing as far as trying to figure out where that sort of dissonance is derived from, I'd be interested in seeing if anybody has actually dug into differential Snell's law as opposed to
differential Snell's law cannot be applied to an observation through the atmosphere, where we don't have the conditions that would be possible to use the differential version of Snell's law in a real world observation, right? That could possibly be because that could be used in a lab setting, right? In a controlled setting where you had a steady change within the medium of the refractive index, not in a system that's constantly changing and shifting, and you're unable to validate exactly what's happening with the refractive index between point A and point B. You're not able to show a single observation that anyone's done throughout all of the history of humanity where they've used the different version, right, of Snell's law that would apply to a single medium.
Yeah, that's what I'm saying. I don't understand.
Even the mainstream sources say that wouldn't be applicable to a real world situation.
Oh, no, I think it is applicable. It's just not. You just can't. You can't. You don't use it. Know what everything. It's like Navier-Stokes, right? For fluid dynamics, you have to understand how each individual molecule is interacting with every single individual molecule around it, right? So to actually understand how the light is passing through a non-uniform medium over large distances, the computation would be insane, and to do a real world observation would be nuts. But I'm trying to understand where the gaps are that are causing this dissonance between, macroscopic view of our surroundings versus terrestrial long distance observations.
Yeah,
so,
you would also need to take take into account the meteorological conditions that would be necessary. Right, it's almost like a situation where you would have to go out and have your shins burning and your kneecaps freezing at the same time because of the crazy difference in the temperature gradient vertically.
Okay, yeah, exactly.
And have that consistent over a huge distance, right? But we don't have the framework or whatever you want to call it for that situation to be present, because if we know the water temperature is say 40 degrees and the air temperature is also 40 degrees, okay, and we're doing the observation over say 10 miles over the surface of that water where we know the temperature of the water, we know the temperature of the air, okay, we don't have a windy day or something like that, we have very stable temperatures and we're using infrared. Okay, we don't have the setup for this extreme refractive index, essentially a duct to be creating this.
But how can you claim that the air is quote unquote the same temperature as the water, whatever temperature you're claiming it is, right?
Okay, just for example,
it's a three-dimensional medium, right?
Well, for example, we can use the data from a buoy. We can use a buoy, right? That's in the observation, right? That's local. Okay.
Exactly, right. You can approach
so that's
differential Snell's law, right? You can approach. You can have a buoy every X number of distance that is able to give you the gas conditions. So then you can we could draw control volumes around each of the buoys halfway in between, and then it's not one medium into another like one Snell's law, but you could increase your data resolution to get closer to differential Snell's, right?
Yeah, it's still not going to work. It's still not going to account for the observation. Okay, you can't even replicate what you guys are claiming is happening on a small scale. We can replicate all of the real world conditions. We can replicate inferior mirages sinking all of these things, it's very easy to replicate things disappearing bottom up over a flat surface on a small scale. But when you guys are claiming that you can have a curved surface, right, that has something physically hidden behind it by a large amount, right, and then you're manipulating the conditions over the, in the small scale test, and then all of a sudden the curved surface is completely flat, right? There's no distortion, there's no optical distortion, and everything's visible, and it looks like it's all just flat now all of a sudden, magically. Right, that's not even possible to replicate. No one's done that. That's not possible. It's even silly to suggest such a thing, because it would be outlandish to suggest that refraction could do such a thing, because it cannot.
All right, computer's back up and running. I'm gonna hop on mute for a bit. I have a call at 11, so I got like 20 minutes here. I'll be sure to get y'all the data you're interested in. But I'm gonna try and actually get y'all something, or else put egg on my face and concede. In 20 minutes if I'm not able to find anything. But until then, I'm gonna hop on mute, but I'll still be here.
Okay, thank you.